Hello, everyone. I'm Carol. I'm a Women Tech Maker Ambassador, a GDG organizer for the Tampa Bay area, and a GDG mentor for the Southeast region of the US. I work as a web application developer. And today, I'm really happy that you all could join us for this next session with Navati. She's also a Women Tech Maker Ambassador and an iOS developer at Loblaw Digital. So, in this session, she's going to talk about how you can get started with Firebase Firestore. And during the session, you can post your questions in the chat. And if she's ready, I'll hand it over to Navati.
Carol, actually, we are having lots of technical issues today. I don't know why. Mercury is in retrograde or something. It should be. Sorry, like everyone. So we are waiting for our next speaker to just come on time here. Meanwhile, like I said before this session, so just grab some waters, stretch a little bit on your chairs. If you're like on the couch, just move a little bit, and then we will just start shortly. Once again, sorry about that. And then, today is kind of not the day, but we will just make it up with the raffle prizes that we are giving out. So please make sure, fill out the feedback survey that you are getting from us. So that way you can win, lots of other, gifts. Yes. So now actually I see our next speaker joining us. So I will hand it over to her. And then Carol, thank you for the introduction. That was amazing. And then, let's maybe have Navati here. Hey, Navati.
Okay, great.
Hey folks, can you guys hear me, see me?
Yes, we can hear you, see you. And then I will stop screen sharing, and then you can just share your screen if you want from the button screen share. And then, the floor is yours.
Perfect. Just give me 1 second here. So can you see my screen? Just want to confirm once again. Okay, I'll start. So thank you folks for joining this session on how to get started with Firebase Firestore. So today we learn what Firestore is and how you can adopt it in your apps. So let's get fired up. So my name is Navati and I work as an iOS engineer at Loblaw Digital in Toronto. And you can find some of my handles here. And if you'd like to connect with me for a cup of tea, which is, by the way, my favorite drink, then please do reach out. And also lately I've gotten into adopting plants. So if you want to give me some tips on how to keep them alive, then let's chat. So today I'd like to talk about Firestore, as you know, and I want to help you understand some of the core concepts so that you can go ahead and start building your app. Now, being an iOS app engineer, my examples are in the Swift language, but the code would look very similar in any other language as well. So we'll look at what Firebase is at first and see what services it provides, and then compare the two types of database, which is relational and NoSQL. And then we'll build a Firestore database together with an example. So Firebase is a platform that can support your app dev journey in multiple ways. So if you are a front-end engineer like me and you're coding for web apps or mobile apps, you focus more on the front end. And I find Firebase very handy from that perspective because they handle a lot of the backend stuff where you may not have the expertise. It also does support server-side applications, and there are many other services that they provide that can help you in maintaining and releasing your app. And I'm going to show you a list in the next slide. So when you open the Firebase console, you see a very nice, friendly, colorful web page, right? And if you look at the left panel, you can see a menu of the multiple services that Firebase offers. So there are several services for building your app. There is authentication, which can help you authenticate your app. There is also a Firestore database. That's what we're going to learn today together. And if you notice, there's also real-time database out here. This is another database service that Firebase offers, and there are some differences between the two, and I will also go over that. They also have, cloud functions, which can help you with serverless computing. There is storage, there's machine learning. There's a lot of building services for your app development. There's also a lot of popular services for release and monitoring. There's Crashalytics, which can help you keep track of your crash logs and reports. And there are many other services like performance, test lab, app distribution, and so much more, like analytics and engagement. You can do things like A/B testing, remote config. So basically, Firebase is really, really handy for app development. So let's do a quick comparison of the two types of database. There's the relational database, and then there's NoSQL. So when you think about a relational database, it is schema based. And I'll just get into what a schema is. But typically, it is implemented as tables. With NoSQL, on the other hand, there are non-tabular formats, and we'll look at some of these non-tabular formats. But keep in mind that the two database services that we just saw with Firebase, that is real-time database as well as Firestore, both of these services are NoSQL. So you may be familiar with relational database, but let's have a quick refresher. So when you talk about relational database, think of a spreadsheet, like a Google spreadsheet. This is essentially a table. There are rows and there are columns, and there is a schema. So, things like there should be a certain number of columns. There should be a primary key so that you can uniquely identify your rows. You'd also want things like relationships between your tables. So that's what a schema is. It's an outline that describes how your database is organized. So let's look at an example. This is a list of some of my favorite TV shows, and if any of these look new, you haven't tried them, then I highly recommend that you check it out. But in this table, as you can see, that there are various columns, and we can use the first column, the series ID, as the primary key so that we can uniquely identify each of these rows. I could have another table which would give me the episodes of these different TV shows. And then I can have the episode ID in here, the first column in here, as the primary key for this second table. And to create a relationship between these two tables, the TV series and the episodes, I would use a concept called foreign keys. So foreign keys are like a borrowed column, like a reference column. And in this case, the highlighted column, the series ID, is the foreign key, and that would help me establish a relationship between these two tables. So if you look at the first row in here, and the first row in the first table is linked to the first table. In the first table, they are linked together because of the same series ID, and so is the second row. And now we have a relationship established. Similarly, we can do that for the other rows. And so you can see that in a relational database, there are several constraints with the schema, as well as there are relationships. And with this, there is a challenge that it gets really resource intensive. So when you want to deal with more demands, then you need to scale vertically. Scaling vertically means that you're trying to invest in the processing power of your host machine. But when we talk about NoSQL does not have this rigorous schema-based approach with all these constraints and formatting rules. So scaling is faster and easier, and it can be scaled with a horizontally scaled approach, which means that you distribute the database across several machines. Here, the focus is on speeding up the queries, and it makes it very flexible to add fields. So, as we just discussed, that NoSQL can be implemented as a non-tabular format. So, let's look at some of these formats. There is the key value approach, where there is a key and a value. And an example of such a database is Redis. There's also the wide column based approach, where not all rows need to have the same columns. Cassandra is one such database. We also have the graph-based DB, where entities are nodes with static relationships, like in social networks. Neo4j has this approach. And finally, we have the document-based implementation, where there is a JSON-like document, and MongoDB is such an example, and so is Firestore. So let's quickly compare what the difference between a relational database versus a NoSQL database. So as we just mentioned, that a relational database is table-based. It is schema-oriented, and structure really matters. And it is typically implemented like this. NoSQL, on the other hand, is non-tabular, and it is schema-less. It has less constraints, and it can be implemented in various ways, as we just saw. The advantage of this is you have a more flexible structure. So relational database is still really, really great because your queries are more customizable. So if you have used SQL or SQL, you might be familiar with how flexible it can get in terms of running your queries. You can add joins, you can add a lot of filters with a where clause. So that is a great plus with relational database. On the other hand, with NoSQL, it's more applicable for scenarios where your access pattern is known. That means you know what kind of queries you plan to run. The benefit here is you have better performance and lower latency. And as we discussed, a relational database scales vertically, whereas with a NoSQL database, it scales horizontally. So if you want to kind of visualize this, think of vertical scaling as an apartment building where you stack floors, whereas with a NoSQL DB, which scales horizontally, think of it as adding more houses in the neighborhood. So it would look like this. Now let's look at some of the key features of Firestore. First, Firestore is a document-based DB. That means in here there is a JSON-like structure. There are keys and values. So the key is the field and the value is the value that it holds. So I could have the name as the key and the value as Kelly, or age as the name and the value is 15. So you can have simple key and value fields, and you can also have nested fields, like in this example for address. So the documents are JSON-like in Firestore, but it's much more than that. I want you to keep this visual in your mind. So Firestore is a collection of documents. Collection of documents is like having a folder with many files. So let's look at an example. Let's say we're back in school and we have a database of students. I could have a student called Kelly, and I can store some information in a document about her. I can say, keep track of her name, her address, her major. I could have another student called Raj, and again have that similar information, right? And I would put these documents in a collection because Firestore is a collection of documents. So this would be my Firestore database. And I can also have even more information where I keep information about the courses that these students are enrolled in. I could have a document for the algorithm course that Kelly is enrolled in and keep information like her course name, her course code, the professor, and maybe another course called C++. And now Kelly's document not only has some information, some data inside it, but it also points to this collection of documents. And as you can see, I'm using this schema. I'm using the pink color for documents and yellow for collections. I just want you to keep that in mind for all my upcoming examples as well. In the same way, Raj, his document can also point to a sub-collection of documents. And now, as you can see, things have started to get hierarchical. You can even take this a step further and have another collection of documents, maybe for the assignments that they handed in for these various courses. And now this could be how the school database looks. So this is a great advantage with Firestore. It gets pretty flexible, and I'm hoping that you are getting some idea of what a Firestore database looks like. So keep this in mind, Firestore is a collection of documents, and it always begins with a collection. At the very base, at the very root, you always begin with a collection of documents. Documents have some data inside, and they can also point to another sub-collection of documents. So it can look like this alternating pattern of collection and documents. And at the base, like I said, there's just one collection of documents. I mean, it's not necessary that there's just one collection of documents, but you definitely need to start with one. You can have multiple collections. It can be parallel at the same level of collection. So for example, the first collection could be for the students and the second collection could be for the professors, right? And also when it comes to documents, the documents can point to more than one sub-collection. It's not just one. We could have our professors have documents for the other fields, like maybe the research they do and the projects they teach and the employment information. So Firestore is pretty flexible in this way. Now, when it comes to retrieving a document in Firestore, keep in mind that you're retrieving the entire document. You cannot retrieve it in part. So if you want just a couple of fields and not the rest, well, you don't have that option. So keep this in mind. So there is a limit to the size of your document. It is 1 MB and 20,000 fields. And when it comes to queries, queries are shallow, not like Lady Gaga's shallow, but like this. So let's go back in this example with the students. Let's say I want to fetch information for Kelly. When I ask for Kelly's information, then I'll get all her data from her document, but I'm not going to get any of the things that are below her or beneath her document. I'm not going to get any of this sub-collection information. So that's what we mean by shallow. When you ask for Kelly's information, you're just going to get that document and nothing below. And I also want to mention that Firestore has security rules. So security rules help you control access. You can create rules around who can access which documents and which student in which collections. So let's say if there's a Snoopy student trying to figure out what the other student scored in another subject, well, you can prevent all of that with security rules. And security rules can also be used for creating validation rules. So if you consider grades could be a percentage. They could be numbers between 0 to 100. So you can enforce that with security rules. So even if a student is like super brilliant, they cannot get 200 out of 100. Now, I mentioned that there are two different database services by Firebase. There's the real-time database as well as Firestore. So let's compare them quickly. Real-time database is a simple JSON tree, like in this screenshot. So it does not have that collection of documents kind of a scheme that we have with Firestore. So for more complex data, Firestore is a better choice. Real-time has an extremely high uptime guarantee. Firestore's guarantee is just as good, but for more critical stuff, real-time DB would be more reliable. And when it comes to queries in real time, they are deep by default, and you can access granular data, which Firestore does not allow. Firestore is, the queries are shallow, and you would be given the entire document when you retrieve it. So now let's apply this knowledge into an actual database. Now, I love learning outside of work. I like attending meetups and conferences just like today's. And I'm guessing you guys also enjoy that since you're here. And I also like building apps, like side projects. And our field is such where there are constant updates. So I like learning through books and courses. and also making connections and networking. And if you can relate to this, you might find it overwhelming like I do. I tend to look like this. I get really stressed. And so I thought perhaps I can create an app because I'm an app developer and maintain the database for this using Firestore. So let's look at what this kind of a database would look like. So as we discussed in Firestore, it is a collection of documents. So keep this in mind. You have to begin with a collection of documents. So let's start with our base collection. We can have a collection of these different activities. I can have a document for a meetup that I attended on Android, maybe a workshop on blockchain. I could have another document for a course that I did online, and maybe a book that I read. So now I have my base collection established, and my DB is, I've begun my DB, right? Let's add some data in these documents. So consider some of the straightforward fields. I can have the name of the event. I could have the type of the event, whether it was a meetup, a conference, an online course, and other relevant information like the organizer of the event. If it was a course, I could have the instructor, and if it was a book, maybe the author, right? And I can also have a field for the rating. So the rating could be a number, and like I mentioned, you can use security rules to ensure that this is a number between maybe 1 to 10. So let's look at what a query would look like. So if I want to run a query and find out how many of my events were meetups, I would first need to create a Firestore reference, a reference to my Firestore DB, and then a reference to my activities collection like this. And once I have a reference in here, I can run a where field clause and find out how many of my activity types is equal to meetup. And if I want to find out how many of my events did I enjoy, maybe my enjoyment threshold is 7, so I can run a query and say, okay, so where field rating is greater than 7. So these are some of the simple queries that you can run with Firestore. And also I want to mention that Firestore uses indexing. So while you are storing data, it can be a bit slow because behind the scenes there's so much indexing going on, but retrieving data is so fast that it's really worth it. And that's typically what you're doing when you have an app. You're reading data and retrieving data. Now, in any of these activities, I'm typically working with different skills. Like in this Android meetup, I'm probably learning some Android, Kotlin, or Java. And I can keep track of these different skills as an array. I can also run a query and find out how many of my meetups in my activities collection did I work with skills such as Android and Kotlin using the array contains any clause. And hopefully you can see that it has been pretty straightforward and simple. So let's look at a quick demo of the Firestore console. So I hope you can see my screen. In here, as you can see on the left panel, there are various services that we just talked about in Firebase. I have the Firestore database clicked in here, and that's why I can see my Firestore DB. And as we know, it is an alternating pattern of collections and documents. It begins with a collection, and my first collection is the activities collection. And if I wanted, I could have more collections right here. I can create more collections in parallel at the same level as activities. And inside this activities, I can see the various documents that we created. And if I click on any of these documents, then I can see the fields, which are basically key value fields. And I can also create sub-collections either here or through code. In this example, you can see a sub-collection as well as data. And if I click on the sub-collection, I can again see more documents. And these documents can have data as well as sub-collections, and it goes on. So now let's talk about write-ups. So when I attend an event, I like posting about it, whether it is through like Instagram or Twitter or LinkedIn. Perhaps you guys do that as well. And I'd like to talk about how we can maintain all of this on our database. So one way to go about it is just store it as a long string, like in here, just store it as another simple field, right? That's one way to go about it. But another way to go about it is storing it as this nested JSON, where I can also keep track of associated fields, like the date that I posted this on, or which platform I posted it on, maybe Twitter or Instagram. And this nested JSON structure is considered as a map in Firestore. Now, this is definitely one way you can go about it. You can also have an array of these maps, but I want you to consider what it would look like when you have built an app. So I've created a sketch in here of my app, and in here I have various fields. As you can see, there are these different rows, and in here I have a quick summary of all my activities. I could have the name of the event, the type of the event as well, and the organizer. But you can see that some of the fields are not displayed just yet. I could display them on the next screen when I click any of these rows. It would look something like this. I could have the same information and additional information like the rating, the skills, and even the write-ups. It could scroll down and show me because my write-ups might be really long. Now, if I'm planning to just display, some of the basic summary information in here as a table, and then if the user doesn't really click on any of these rows, they just look at the basic summary, then you might be giving them more information. You might be downloading more information than you're actually displaying at this point of time. So if you have multiple write-ups, let's say you have several write-ups or any such field which has you're downloading more than you need, then you might want to consider separating this and placing this in a sub collection. So consider this trade-off when you are building your apps. So if I were to represent my write-ups as a sub collection, then it would look like this. I would have my document for my activity, and then I can have another document for each write-up, maybe one for LinkedIn, one for Twitter, and then one for Instagram. And now I can have my activity document point to this sub collection. And so this is what my DB would look like. So if I consider another example where each of my activity collections, activity documents point to their own sub collections, then my DB looks really hierarchical now. And I could even have documents which probably don't have a sub collection. Maybe I never wrote a write-up, so that's all the flexibility we have. But consider this. Let's say I want to run a query and find out how many of my activities did I post about on Twitter. So for that, I would need to consult the sub collections of the various documents. There's a sub collection for the first document in here, and then there's the second sub collection for this document. So I'm asking Firestore that can you please go and look at all my sub collections and then run this query. You're asking Firestore to kind of pretend all these sub collections were one collection. And when you do that, then you need to use a collection group query. And I just want to mention that because that would require a little different code. It's just a slight difference, but it would index things a bit differently when you do that. Next, remember back in the day when we would go for these events, then you get to learn a lot, of course, in tech events. And also, for me, my favorite part was getting the free food, but also, yes, definitely making connections and meeting new people. So let's talk about how we can add some of these connections in our database. So I could, again, keep track of all my connections in their own documents, right? So maybe I want to keep track of information such as where I met them, in which event I met them, or what they do. And I can store all of that as, again, a very similar sub-collection structure that we just saw, right? That is definitely one way to go about it. Another way to go about it is I could separate these connections as another top-level collection. So that would look like this. So I have my activities collection that we had started off with. Each of these documents can point to their own write-up sub-collections, right? And then I can have my connections in the same level as my activities collection. Now, this is at the top level, right? And you can decide which approach to go with. You need to figure out what kind of queries you're going to run. If I want to run a query where I just want to know things about my connections, and it's the query is independent of these activities, then this kind of approach would make more sense. So, for example, if I want to look at all my connections that I made through all these events and find out how many of them work at a certain company, right? Then this approach makes more sense because I don't need to put them in a collection group query. And you can also go further and add more things about these folks, and maybe you want to keep track of the different conversations or some notes about them. So here this would look like our final DB. So let's wrap up. We talked about how Firestore is one of the 2 database services that is offered by Firebase. It is a NoSQL DB, and it is implemented as a document-based DB. And the important part of Firestore is that it is a collection of documents. So remember that the documents are retrieved as a whole and not partially. And you can only run shallow queries. And the beauty of Firestore is that you can leverage Google Cloud services, and they take care of all the backend stuff like scaling and setting up servers. And Firestore has a really robust client library. They offer security rules for access. It is near real time. They have a strong reliability, and it's really easy to set up. They also provide offline support. They support transactions, pagination, and so much more. And as you have seen through these examples, that it is quite flexible. And that's really good because in app development, you want something that is iterative. So Firestore really supports that. And they also have offline support. They support transactions, pagination. So there's a lot that's amazing about Firestore. And I feel like I'm having my cake and eating it too. These are some of the references that I use. I primarily use the official Google Firebase documentation, their videos, and with Google I/O around the corner, you can learn more about Firebase and Firestore as well. So do check that out. Thank you so much.
Thank you. I think we have time for a couple of questions. Let's see. Okay, so what resources would you recommend to people who want to start their projects in Firebase Firestore?
So yeah, I primarily used the official videos. I really enjoyed that, the ones that were provided on the Firebase docs. And recently, I also noticed that Google also has this really nice sketch notes. So I think those are great resources to get started. I spend most of my time just watching the videos and also looking at the official blogs. So I highly recommend that.
Okay, great, thanks. And I think we have one more question. Is there a limit on how much nesting you can do?
Yeah, that's a great question. So since it is pretty hierarchical, you can go quite deep, but there is a limit of around 100. Like the limit to nesting is 100.
Okay. And does that affect your queries, the optimization? Like, does it take longer to query?
I mean, you'll have to go in that kind of a depth. So you will have to use additional queries, and you need to consider that as well.
Okay, great. And I think we have one more question. Is Cloud Spanner the best of both worlds?
I wouldn't know. So I'd love to know more from you, Anna. But yeah.
Okay. Yeah, maybe one of our Google experts could answer in the chat. And another question, am I correct if I say the real-time database is a document store?
Yeah, it is also document based.
Okay, so and is Firestore rather a key value store than a document store, or is it a hybrid?
So it is also document based. When I try to figure out the difference between key value versus document, what I understood is when you have a document based DB, your database is aware of what is stored, and that helps with indexing, and it has more knowledge about what's going on. And key value is supposed to be, in my understanding, more simple than that. So it is a document based DB.
Okay, great. Thank you.